Welcome back to the Neuroethics Learning Collaborative. Tonight's lecture is on cognitive enhancement. This is my turn to actually do some of the work for the course. I'm the course director, Martha Farah, and I will be giving this lecture and the next one on brain enhancement. Okay, so let me just overview where we're going in this lecture. We're going to start by defining what a cognitive enhancer is. Then we will take a quick review of whether stimulants, which are the most frequently used class of drugs for cognitive enhancement, whether they work and how they work. We'll talk a little bit about the epidemiology of stimulant use for cognitive enhancement. Review other kinds of drugs and devices that have been or could be used for cognitive enhancement. And finally, because it's the Neuroethics Learning Collaborative, we will review the ethical, legal, and social issues involved in cognitive enhancement. So starting with the definition. What is cognitive enhancement? Well, the key idea here is that it involves taking a cognitively normal person and improving their cognitive abilities. It could result in high normal cognitive abilities, but still within the range of normal, or it could actually result in people having a higher level of cognitive ability than is normally found in the human species. But the point is that the starting point is itself normal, and that contrasts with therapeutic treatment or cognitive therapy. The idea of cognitive enhancement was first discussed explicitly as a goal for medicine by, you know what? Do you know how to pronounce this fellow's name? We have a Bulgarian here, and so I thought she might know Romanian pronunciation. Well, I'm going to try Corneliu Georgia, but that may not be the right pronunciation. But in any case, in the 60s, he began to work on drugs for enhancing cognition, and he's known for this statement: man is not going to wait passively for millions of years before evolution offers him a better brain. So his call to arms was, you know, get off your duff and start trying to improve that brain and improve cognitive ability for the human race. Most cognitive enhancing drugs started out as treatments for various kinds of neuropsychiatric illness. Again, although we define cognitive enhancement as taking a normal person and making them better than they were before, it's hard to think of any examples at this point of drugs that were developed just for that purpose. So really the pathway through which we get cognitive enhancers today is that they are sort of off-label, if you will, uses of neuropsychiatric drugs. The most commonly used neuropsychiatric drugs are the ones that are widely used for the treatment of attention deficit hyperactivity disorder, the sort of, you know, classic prescription stimulants. And that's what we're going to talk about now, how they work, what they do for people. The most widely used cognitive enhancing drug in the US, as far as we know, and we'll get to the uncertainties of epidemiology in a minute, but it would appear to be amphetamine. Most commonly, the mixture of amphetamine salts, predominantly dexamphetamine and other amphetamine molecules mixed in, known as Adderall. Methylphenidate, Ritalin, is also widely used, and these are both drugs that are mainly sold legally as treatments for ADHD, but as I said, find their way into the hands of normal, healthy people who want to increase their normal attentional functions, their normal attention span, to make them to make it even better. Now, how do these drugs affect cognition, whether in a healthy brain or an ADHD brain or other kind of brain? Well, they do so via their effects on catecholamine neurotransmission, norepinephrine and dopamine, but primarily the cognitive effects are from the effects of the drug on dopamine. As you can see from this diagram of the dopamine pathways, there's dopamine throughout many parts of the brain and body, for that matter. And as a result, you will not be surprised to learn that the effects are quite broad. They have cognitive effects, and from the point of view of cognitive enhancement, they have side effects as well. We see the mesolimbic branch of the dopamine system that includes the nucleus accumbens, an important part of the reward system, and it's the engagement of the reward system by these drugs that gives them their addiction risk, and also the mesocortical system that provides dopamine to prefrontal areas that are mainly responsible for the cognitive effects of these drugs. What are the cognitive effects of these drugs on normal, healthy people? Well, I have to say the literature is somewhat mixed. From my reading, I would say that the most consistent effects are found, surprisingly enough, in memory and learning tasks. The slide that's up now shows data from a learning study by Breitenstein and colleagues, where a dose of amphetamine during the sequence of learning trials over, I guess it looks like 5 days, results in sort of cumulatively better and better learning for the people who were taking the amphetamine relative to the placebo. And interestingly, when tested a year later without any drugs on board at all, right? The subjects who had taken the amphetamine while they were learning, a year later without any drugs, still retained more information than the people who had taken a placebo. So it looks like these drugs, at least under certain circumstances, or at least amphetamine, at least under certain circumstances, does enhance learning. In terms of executive function enhancement, the data are a little more mixed. It appears that one reason for a lot of null results in the literature may be that how they affect a subject depends on the individual characteristics of the subject. So some people are helped by these drugs and some people are not. This slide comes from the work of Matte at NIMH, who gave amphetamine to normal subjects and looked at their performance on the Wisconsin card sort test, which is a fairly standard clinical test of executive function. And what he found was that the effect of the drug, the drug's ability to decrease errors depended on people's genotype, specifically what variant of the COMT gene, which is a gene that's involved in dopamine neurotransmission, which version of that gene people had. So the people who were homozygous for the VAL allele showed a pronounced effect of placebo versus amphetamine. So overall, they were worse, right? If you just look at the average performance, or you just look at the non-drug performance of subjects, you can see that the VALs were making more errors, but they were quite substantially helped by the drug, whereas the other people didn't really show a significant effect one way or the other. You can also see differences in the effectiveness of stimulants like amphetamine or Adderall, depending on just how, leaving genes aside, just in general how well people do on the task in question. So here is some data that we collected a few years ago here. And I think the thing to first look at the right-hand panel, and you can see that for this embedded figures task, which is considered a task of convergent creative thinking, the ability to see kind of the non-obvious configuration in a geometric pattern. The people who were doing pretty well on the task in general didn't show a benefit. The people who were below the median did show a benefit. But what's really interesting is if you look at the left-hand panel, this is a verbal task, the remote associates test. It's a test, again, of convergent creative thought. Here's an example of one of these problems. What word goes with all three of the following words? Black, rasp, and straw. Give you a minute to think about this. Well, berry, good going. Okay. Blue. These are difficult, tests of creativity, and here we see that the people who are overall doing better, the right-hand bars on the left-hand panel, actually get worse on the Adderall, whereas the people who were doing below average actually get somewhat better. So, the bottom line is these drugs, certainly amphetamine, which is the data I showed you here, but also similar findings have been obtained with Ritalin. These drugs may help some people with some aspects of cognition, sort of some people some of the time. But they're certainly not, miraculous smart pills that will make everybody do better on everything. Epidemiology. I mean, despite the fact that the laboratory data seem to show, that there are some effects, but they're not killers. They're not huge effects. People are using these drugs. I'm sure you were all shocked, as who's the police chief in the Humphrey Bogart movie. Shocked to see that gambling is going on here. I'm sure you're shocked to hear that students on this campus and on many campuses around the country and increasingly now around the world are using Adderall and Ritalin as study aids. Even though they have not been prescribed these drugs, and most of them do not meet diagnostic criteria for having any kind of illness for which it would be appropriate to prescribe these stimulants. We know certain things about who's using these drugs and why. There's a lot we don't know, and given the dimensions of the problem, given the number of young people that are using these drugs, clearly we need to know more. Let me tell you a little bit about what we do know. The biggest and best designed study so far for answering this question was done by Sean McCabe et al. And published in 2005 in the journal Addiction. They sampled almost 11,000 college students from all over the country and did a stratified random sample so that they had people of from different geographic parts of the country, from different types of colleges, from different socioeconomic status, racial diversity. It was all controlled for. And what they found is a lifetime prevalence of using these drugs without a prescription, using them non-medically is the term they use, but almost 7%. Almost 7% of American college students, according to this survey, have used these drugs at least once. The rate varied dramatically from campus to campus. On some campuses, essentially nobody had used the drugs. On other campuses, 1 in 4 students had used them in the past year. They were able to make some generalizations about the demographics of who uses them, where, and why. The rates, you're probably not surprised to hear, are higher on the east and west coasts. They're higher in private institutions, institutions with competitive admissions policies, very much like the campus that we're on here. And as I said, I'm sure your graduate students, I think this is more of an undergraduate phenomenon, but I'm sure you're not truly shocked to find this out. Now, the reasons that people are using these drugs, the ways in which they're using them, the frequencies with which they're using them, we have some information about, not that much, and certainly not based on the kind of really big representative sample that McCabe et al. Used. But clearly, the most common reason for using them is as a study aid, so is as a cognitive enhancer. But people also use them to party. They can stay up later partying, they can drink more and not fall asleep. And they use them for weight control. So they're not just being used as cognitive enhancers, but that is the most commonly mentioned reason for using them. People take them as pills, they snort them. Some people even grind them up and inject them. It's really a horrible thing to think about. That stuff is not meant to go directly into the bloodstream. A lot of students say they use them once or twice in the semester. Some people use them every week. So there's a huge range of practices, a lot we don't know. What about people other than American college students? Is this just a college phenomenon, or are people in the workplace also using these? Again, we have much to learn here. There are some big national surveys that have been going on for many years that do use large national representative samples and ask them about various kinds of drug use. But these surveys, although they tell us a lot about drug use of all of our fellow citizens, they don't tell us much about cognitive enhancement uses. So they don't distinguish between non-medical use to as a study aid or to get more work done versus non-medical use to for the high that it gives you. So much to be learned there. There is one survey that's gotten a lot of attention of academics. So again, we're still on a campus, but we're talking about professors now. And this is a poll that was conducted by the staff of Nature magazine and published in 2008 with the title "Look Who's Doping." And they found, I confess I did not recently review these data, but I'm pretty sure it was about 1 in 5 of the poll's respondents said that they engaged in some form of pharmaceutical cognitive enhancement. And when this study came out, it got press coverage all over the country, all around the world, and people were quite shocked and upset, and I suppose understandably so. But I want to raise a little caution about accepting the conclusions of this poll at face value. So this poll suggests that 20% of college professors, or, well, not college professors, right, readers of Nature, professors who read Nature, use cognitive enhancement. But it's the sample, we've already qualified the sample once. It's not college professors, it's readers of Nature. But it actually needs to be further qualified. It's 20% of readers of Nature who bothered to respond to the poll, right? That is not a representative sample of readers of Nature. And my little line about the Vermont vacation problem refers to this analogy that I think will help you see the problem. Let's say you're a magazine, let's say you're a travel magazine, and you conduct a poll about Vermont vacations, and you ask people who takes vacations in Vermont, who thinks Vermont is a good place to go on vacation, even if they haven't gone themselves, who thinks other people should go on vacations in Vermont, and so forth, right? Well, you're going to get a large fraction of the respondents being people who take vacations in Vermont, and if you try to estimate the number of total people in the world or even in the readership of the magazine who actually do go to Vermont on vacations, you're going to be overestimating that number, right? I mean, people who, go to the Caribbean on vacation are just much less likely to respond to a poll about vacations in Vermont, right? Similarly, the people who respond to this are going to be people who have a personal interest in cognitive enhancement, much more likely to be people who are doing cognitive enhancement themselves. So just, a caution, this 1 in 5 number is not really a reliable estimate, IMHO. Okay, so we've seen that the stimulants are somewhat effective, fairly widely used. How else might one cognitively enhance? What are some other drugs that one might use, and are there non-drug methods? Well, first of all, turning to the drugs, there are drugs that affect other neurotransmitter systems. Atomoxetine has been used in the treatment of ADHD. There has been a little bit of research on its effects on cognition in normal, healthy subjects. It seems to have some effects. As far as I know, it hasn't caught on as a campus drug. It has the advantage of being safer than the amphetamine and methylphenidate, less likely to cause dependence. But that is another sort of pharmacologic approach to cognitive enhancement. There's donepezil and other kinds of drugs that work on acetylcholine. These are drugs that were originally developed to treat Alzheimer's disease and have been shown to have some modest effect on learning and memory and executive function in normal, healthy people. There are a couple of drugs whose mechanisms of action are not well understood. Modafinil was originally developed as a drug to treat various kinds of sleep disorder and the fatigue associated with sleep disorders. And piracetam is a drug that was introduced as a possible way to improve cognition in people with, I think in this country it was considered for the sort of cognitive after effects of electroconvulsive therapy, but I don't think it's actually approved for anything in this country. And again, it's with both modafinil and piracetam, there are various theories about how it affects different neurotransmitter systems, but unclear at the present time. And finally, there are a bunch of different companies formed in many cases by molecular neurobiologists whose careers have focused on understanding the molecular mechanisms of memory formation. And these companies have begun to use what's understood about memory formation from the lab to design novel drugs to improve memory. And the hope here is both to find a treatment for age-related memory decline and dementia, but also to enhance just normal, normal flagging middle-aged memory, with which I am all too familiar. But this class of drugs, about which there's a lot of excitement, nothing from this kind of generation of drugs is on the market yet. In addition, in recent years, we have seen work being done on devices that can alter brain function and thereby alter cognition. TMS, transcranial magnetic stimulation, which you see in the upper picture, is a method that, as you know, involves inducing a weak current in the brain using magnetic fields. It has been FDA approved for the treatment of depression in certain specific kinds of cases. And in addition, it does seem to have some effects on mood and cognition in normal subjects. Transcranial direct current stimulation, which you see in the lower picture, you can see the two electrodes sort of taped to the guy's head, is, well, I was going to say a newer technique. It's actually an older technique, but it's more recently enjoyed a resurgence of interest. And TDCS, interestingly, has in the few years that it has been a topic of research among cognitive neuroscientists, there are a lot more demonstrations of enhancement of normal cognitive function using TDCS. Interestingly, it's pretty low tech, and there's online chatter that you can find amongst sort of engineering chat groups and so forth, where people just try this at home, like with a 9-volt battery and some saline and cotton wires. We have people at Penn who are showing this same finding, namely you can get enhancement of various cognitive processes, decision-making, memory, and so forth, using TDCS. So this, one could envision this kind of method being adopted for enhancement, although because it's so low tech, it's probably not going to be commercialized for that, for those effects, because a company can't make a lot of money selling it, because you can just put it together yourself from the drugstore or the hardware store. The last two bullet points are in fainter print. They're not in bold because they're things that we're very far away from using for cognitive enhancement now, but for the sake of completeness, I'll mention them. Deep brain stimulation is a surgical technique that involves implanting electrodes in the brain. It's found to be wonderfully helpful for a range of otherwise intractable movement disorders and mood and anxiety disorders in patients who haven't been helped by drugs. And there's a lot of excitement now about trying DBS for various other problems. Obviously, it's a very invasive procedure, and you don't just pop the electrode in and send the person home. There's a lot of tuning, and monitoring that goes on afterwards. So it's unlikely to be used, for cognitive enhancement by perfectly healthy people anytime soon. But you could imagine a sort of intermediate situation where someone is having, an implant to treat some other condition that they're suffering with, and might opt to have some contacts located in a way that enhances their cognition or their mood, for that matter. And finally, brain chips. This is really in the kind of far distant, science fiction future at this point. But I will just note that there is research ongoing with, live behaving animals with implanted chips to enhance learning. So Ted Berger at, I believe it's USC, has rats in which he can sort of connect and disconnect a silicon hippocampus, I think it's maybe CA1 or CA3 region on a chip, and can enhance the learning of these animals. So, proof of concept in a mammalian brain. Okay, so we've done our survey of the empirical facts of the matter. We've seen that there's a lot that we don't know about the effects of these drugs, who they help, in what ways they help, as well as who's using them and why. But clearly it is something that is here now. It's not science fiction. DBS and chips for cognitive enhancement might be science fiction, but the drugs and perhaps transcranial direct current stimulation are not. What about the neuroethics of this, the ethical, legal, and social issues? Well, the biggest safety issue that I want to raise is the risk of addiction. Particularly the prescription stimulants, they don't just affect your prefrontal cortex and sort of cool cognition systems. They affect what are sometimes called the hot cognition systems. They affect motivation, reward processing, and unfortunately, a certain fraction of the people who begin to use these drugs for cognitive enhancement will end up becoming dependent on them. So that is a concern that has to be noted up front. Another concern is fairness. And I don't know, is the caption visible? Perhaps not. Midway through the exam, Alan pulls out a bigger brain, sort of surreptitiously from inside his shirt. So people often make the analogy between cognitive enhancement and doping in sports, right? And it's certainly true that in competitive situations, a cognitive enhancer that really does work would give you an advantage. Is that unfair? Well, it certainly is. Certainly it is if you're not disclosing that you're enhancing and other people aren't enhancing. That said, a lot of the effects of cognitive enhancement are not directly the sort of giving of an advantage in a competitive situation. Remember that memory data that I showed you. If a drug helps you learn better, one could make the argument that this is a good thing, that it actually is, it's enabling, and will help you go on and become a better scientist and do good work that way. Even in competitive situations like sitting for a licensing exam, for example, I think you can make the argument that if you are willing to always be taking this enhancer, then maybe you should be allowed to take it for the licensing exam. So in other words, it would clearly be wrong to go in to be licensed as a physician, say, having done your studying and sort of taking the exam with this drug on board that's going to make you do better than you would do without the drug if the rest of your career you're going to be practicing without the drug, right? It's kind of misrepresenting the kind of work that you can do. But again, for the sake of being provocative, I'm going to toss out the thought that perhaps as long as you're willing to consistently use it, this is the way, this is my MO. Who I am professionally is Martha on Adderall. Then, I don't know, if I was on Adderall, I wouldn't be stumbling and looking, trying to do word finding right now. Maybe it's not even unfair. Another fairness concern, though, that I should raise is the issue of what's sometimes called distributive justice. inequities in terms of who gets these drugs and who even has the option of deciding to take these drugs. Right now, of course, it's the case that people of higher socioeconomic status have more opportunity to use these drugs than people of low socioeconomic status, in part because of the cost of the drugs, but also just in terms of their access. Upper SES people are much more likely to have the kinds of relationships with doctors and the sort of comfort in discussing with a doctor the fact that, well, gee, I know I don't really meet diagnostic criteria, but it would really help me because when I'm doing my term papers, I need this extra help. These kinds of differences, not just in financial resources, but in basically social resources, who you know and who you can talk to, mean that cognitive enhancement is, the way it's currently practiced, is going to tend to increase the gap between haves and have-nots. And that's of concern. Not only in terms of socioeconomic disparities within a country, but between countries, geopolitically. Certain cultures, certain groups are more likely to be benefiting from these drugs than others. So the fairness issue has many different aspects to it, and it's worth taking quite seriously, I think. Another issue, in some ways the flip side of the fairness issue, is the freedom issue. It's not just can you get it if you want, but or can you take it if you want, but can you not take it if you don't want? One could certainly imagine situations, for example, in the military, where someone is ordered to take a drug, or certainly pressured into taking a drug, and even subtler forms of coercion, in the workplace. If your boss says to you, the other programmers are, using Ritalin or using modafinil, and they are cranking out, half again as much code as you are. I mean, yeah, they pull all-nighters a couple of nights a week, but they can do it. And you're just not pulling your weight, and I certainly wouldn't tell you need to take this drug, but let me just say, there are other people out there that I could hire who would, who do use these drugs. I mean, you could imagine getting the message, and I'm told that people are, in some circumstances, feeling at a disadvantage because they don't want to take these drugs, and it makes them look, like subpar in terms of work productivity. So the freedom to not enhance is not something we should take for granted, especially when and if cognitive enhancement becomes more common in the workplace. In terms of legal issues, you might say, well, if a doctor prescribes Ritalin or Adderall for you and you don't have ADHD, isn't he or she breaking the law? Well, it turns out the answer is no. This article, which you probably don't see the fine print of, but it's called Responding to Requests from Adult Patients for Neuroenhancements, was put out by the Ethics, Law, and Humanities Committee of the American Academy of Neurology. And these authors, Dan LaRiviere, Matt Rizzo, Richard Bonney, and others, looked at this question of what is the proper thing for a physician to do if an adult comes in, a competent adult, and says, for these and such reasons, I think my life would be better if I could have a prescription for X, Y, or Z, or for a drug that will help me do X, Y, or Z. They concluded that, in general, there is no legal or ethical barrier for a physician to prescribe cognitive enhancement to adult 40 minutes, thanks, to adult patients under these circumstances. Finally, the last of the big ethical issues is what you could call personhood, agency, desserts, by which I don't mean cookies and cake, but what do you deserve? And here the issue is, part of being a person, as opposed to just like an object, a machine, is that you have agency. You accomplish things because of your own effort and your own intention. And there is a sense in which tweaking your brain chemistry to accomplish more seems a little bit like this cartoon, right? It seems a little bit like, using gasoline in your car that has some additive that makes it go faster. So, there are those who, like the old President's Council on Bioethics, led by Leon Kass, who felt that there was a sense in which human agency was short-circuited by using these kinds of drugs. And the notion of desserts is, well, do you deserve praise? Do you deserve, should you feel proud of yourself if you got, studied hard and got a good grade on an exam because you had Adderall on board? Should you feel less proud of yourself under those circumstances than someone who got the good grade without pharmaceutical assistance? I think these are they're very hard. They're very hard issues to decide. Certainly worth more discussion than one bullet point on a slide here, but nevertheless, that's, I think, all we can say about them at this point, and that's it for this lecture.